Welcome everyone to the mechanics class. My name is Mithilesh and I'll be teaching you engineering mechanics. In today's session, I'll just give some background, what syllabus we have and some basic things which we need to study in order to understand this overall subject. So first we'll go through the syllabus of this subject and then we'll understand some basics which we need in order to understand all these things. If in between you have any doubts, feel free to put a comment in our chat box or you can ask me directly. So yeah, for our syllabus we have free body diagrams and equilibrium. Then we have topic on friction and its application, on the belt, pulleys, brakes, clutches, screw jacks, etc. So basically the first part of the subject is mainly on free body diagram and equilibrium. Then second is on friction related topics, and then trusses and frames, virtual work. Till this you have the static part of the syllabus, and then dynamic part you also have. In that you have to study kinematics and kinetics. So kinematics and dynamic of rigid bodies in plane motion. So whenever we'll study the dynamics part, we will study both kinematics and kinetics, and we'll study a couple of theorems like impulse momentum theorem, D'Alembert's theorem, work energy principle, etc., and Lagrange equation. So that is the overall idea about your subject. Basically, broadly, you can divide mechanics into two groups. One is static and another one is dynamics. So the overall syllabus is splitted across these two topics. Okay, so we will I'll just first give introduction about the mechanics and then the its branches and then sub branches, so that you will understand the syllabus in detail. Okay, so with that introduction, write down heading mechanics. So in mechanics, it's a branch of engineering which deals with the study of effect of external forces applied on any particle or body. Then that body may be at the rest or in the motion. Okay, so definition itself adds a lot of things here, that we are studying the effect of external forces applied on a body which is in the rest or in motion. So depending on the body, whether it is in rest or motion, we should have different branches of it, right? So the first branch is static, and another branch is dynamics. And what is static? Static is like study of effect of external forces applied on a body when body is in rest, or body is at rest, you can say, or it's not moving. Okay, or you can say it is in equilibrium. Body is in equilibrium. Okay, and if body is in equilibrium, and then we are studying the forces and all, then we say it's a static part. Whereas Dynamics is the branch of mechanics which deals with the analysis of bodies in the motion under the effect of external forces. So here, bodies in motion under the effect of external forces. So basically, half of our syllabus will be focused on statics part, where we know our body is in equilibrium, it's not moving, and we have to apply equations of equilibrium and the logics of friction in order to, um, let's say, study the effect when we apply some forces on the body. Okay, so that is the static part. And in dynamics, it's already known that body is no more in equilibrium, it is moving because of some external forces, and in that we have to uh, study that body under the action of forces or without under the action of forces. So basically, dynamics is further divided into two groups, that is kinematics and kinetics. Okay, in kinematics part, um, so you can say kinematics is a branch of dynamics which deals with the motion of bodies without considering the forces. Okay, so without considering the forces which are actually cause of motion. So, but we'll not consider them while studying this motion. Then we call it as kinematics. So, can you tell me which parameter we'll be studying in this? If you don't consider the motion, with if you don't consider the forces, our focus will be mainly on displacement, velocity, and acceleration. So, basically, we'll consider displacement, velocity, and acceleration. Okay. Whereas in kinetics is a branch of dynamics which deals with motion of body due to the external forces. Okay, uh, considering the, you can say, considering the external forces which are responsible for the motion. So here you will considering the forces. So here you will let's say focus on work energy principle, where you can work is force into displacement. Then we will study impulse momentum principle. Impulse is also related to the force, and D'Alembert's principle. So here all we will consider the forces. Okay. So in this kinetics part, our focus will be mainly on studying the principles: impulse momentum principle, D'Alembert's principle, and work energy principle. Whereas the kinetics part, our focus is mainly on displacement, velocity, and acceleration, because it's a branch of dynamics, deals with the motion of the body without considering the forces. Okay, so that is what there in your syllabus. So if you now go back to the previous slide, you will understand um, the overall topic, that the first half, like this whole part is like related to the uh, static part, where body is in equilibrium. You have to draw the free body diagrams, and if friction is there, then consider the effect of friction, and um, analyze the action of forces on the body. Okay, so and in the second half, which starts from this point, that is kinematics and dynamics of rigid body in plane, impulse momentum, and energy formulations, Lagrange equations. So overall, this part um, comes from the dynamics, where your focus will be studying the body when it is in the motion. Okay, so we'll study all these topics one by one during our course, but In today's session, we'll try to understand some basic things first, so that in the next session we'll be able to draw the free body diagrams, apply the equations of the equilibrium in order to solve the problems. Okay. uh, so the way we will study this subject is, we have some theory part, and we'll parallelly do the numericals on it, because the concept will be clear whenever we study theory and parallelly solve some numericals on it. Okay. So that's how we'll proceed. Majority of our mainly our focus will be on problems. We'll study the basics theory, and then we will focus on problem. Okay. Today's session will be only theoretical basic part, and from tomorrow onwards we'll study the theory things and then solve all possible problems on that part. Okay. Any doubt till this about the introduction of the subject? I assume most of you have already studied this subject, and have some basic idea about it, so that um, feel free to ask if you have any question. Okay. Can anyone tell me, uh, I'm repeatedly using word body here. Okay. Can anyone tell me what is basic assumption in mechanics and the other subjects like strength of materials? What is difference in these two subjects in terms of approach, or in terms of considering the type of body? Um, no one? Okay. If you have studied these subjects previously, I assume you might have just dealt with the forces, reaction, and the moments, right? In the mechanics, we just study forces, then reactions because of those forces, then the moment created because of some forces, right? We never talk about the strain developed or deformation in this, right? That part we study in um, strength of material and other subjects, right? Why? Because here in this subject, the assumption is body is rigid body. Okay. Whenever we are dealing with mechanics, our main assumption is body is rigid. And when we say a body is rigid, if under the action of let's write down first rigid body heading. Okay. So suppose if we have a body like this, and if you have 2 points, point A and point B, for example, and this is the distance between these two bodies. Under the action of forces, so you apply some forces on this body, maybe from this direction, or let's say this direction, or if you pull from any other direction. Okay. Under the action of forces, if there is a very negligible deformation or no deformation is happening on the body, then we can assume that body is an rigid body. Okay. So rigid body is basically, um, you can say, whenever you are applying force, distance between two bodies remains unchanged, then you can call it as a rigid body. Okay. So that is our assumption whenever we are talking about the problems, or the body which is considered in the engineering mechanics subject. Okay. Though it's like, in reality bodies are not rigid, but so as to simplify the assumptions, or so as to simplify the scope, here we are assuming that body is rigid. Okay. Yeah. So that is the first part you should know, that what is the assumption, and the type of let's say state of the body. State is either static part or the dynamic part. A couple of, let's say, some basic laws I would like to present here before we uh, directly start working on the syllabus. So write down heading: law of transmissibility of force. Law of transmissibility of force. Okay, write down this heading. So what is the statement of this law? This law states that whenever body is in at rest or in the motion, okay, body means I'm talking about rigid body, okay. um, so the state of the body remains unaltered, you can say, or unchanged, if the force acting on the body is replaced by another force having the same magnitude and direction but acting anywhere on the body along the same line of action. Okay, I'll repeat the statement so that you can write it, but before that I'll just explain it through small figure. Okay, suppose this is your body, right? And let's say this is the force we are applying on the body at point A in this direction. So if I draw a line which is passing through this force, okay, so this red line indicates the line of action. Okay, so let's call this as a line of action. So I'll repeat the statement, you can write it down. Law of transmissibility of force states that the state of body remains unchanged if the force acting on the body is replaced by another force having the same magnitude and direction, having the same magnitude and direction, having the same magnitude and direction, but acting anywhere on the body along the line of action. Okay, so for example, rather than this P force I'm applying at A, I'm taking any other point, let's say B here, which is along the line of action, and then I apply force P on it of the same magnitude. Then theoretically, you can say, or the both the things, both the figures are same. Okay, or whatever the effect of the force P is creating on this body, if you apply force at A, the same effect will be created on the same on that body if you apply force on B, okay, of the same magnitude, provided that it is applied in the same direction and along the line of action. Okay, so this is the law of transmissibility of force. It is very important because this will help you to simplify your problem, uh, and you can draw the free body diagrams easily and solve the problems. Okay, so this is some basic law you should know. Any doubt in this? Can anyone tell me what is the limitation of this law? Okay, so this law is for the external forces. Okay, I'm not saying for, I'm not using word internal here. Okay, because whenever the internal forces are there, and in that you cannot, let's say, apply this law. Let me give an example here. So these are the external force. So P is here external force. Let's take some another figure. Okay, let's take this bar. Okay, some, let's say, forces or external stresses induced in the body are not, let's say, um, applicable for the law of transmissibility of force. Okay, so consider this figure, and we have some forces P and Q, and these are internal forces, not the external forces, right? Okay, and this is our line of action. So now the P and Q are the internal forces, and they are what they are creating is, you can clearly see it's a tensile loading you are creating on a bar AB. Okay, but if I apply the law of transmissibility of force on this, what will happen is, let's say at point A and B, um, the force P, I will, if I apply like this here, okay, and force Q if I apply here, okay, according to the law of transmissibility of force, it is correct. But the P and Q forces are not the external forces, they are the internal forces. And now the effect is completely opposite, that the body is under compression here. Okay, and it is not, let's say, you cannot say now the state of the body is same as that of previous, right? So hence, whenever we are dealing with the internal forces or stresses, we can say, um, you cannot apply law of transmissibility. Okay, so that is one limitation of it. But whenever we are dealing with external forces, this law helps us a lot in order to simplify the problem and draw the free body diagram. I hope it's clear till this. Okay, this is the first law you should know. uh, Let me give another law parallelogram of forces. Okay, law of parallelogram of forces. So you know parallelogram, how it looks, something like this, right? The opposite sides are parallel. So this law states that if two forces are acting simultaneously at point O on the body and are represented in the magnitude and direction by the two adjacent sides of a parallelogram. Okay. Suppose if we have P and Q force. Okay. If two forces are acting simultaneously at point O on a body, are represented by magnitude and direction by the two adjacent sides of the parallelogram, then the resultant of these two forces is represented by the diagonal in terms of magnitude and direction. Okay, so what is resultant first? Let me just explain you quickly. Yeah, we use this resultant force term very often. So if we have a body, if body is in under the action of a lot of external forces, tensile, compressive, in any direction at any point. Okay, if the system of any number of forces acting on a body is replaced by a single force. Okay, so if it is equivalent to something like this R. Okay, I'll repeat the definition. If the system of number of forces acting on a body is replaced by a single force which has the same effect as that of this total number of forces, then such a force is called as resultant force. Okay, so this resultant force R, use laser pointer here. So this resultant force R is creating the same effect on the body as that of effect created by the all these forces. Okay, so the definition I'll repeat again. If the system of any number of forces acting on the body is replaced by a single force which has the same effect as that of the total number of forces on this body, then such a single force is called as a resultant force. Okay, so now we have two forces here, P and Q. Let me just let's say suppose this is our body, and or we are pulling this body in this direction by force Q and in other direction by force P. So it will create some effect, right? So it will create some effect same as that of if you apply a resultant force on it. And how the resultant will look like? Resultant will be the diagonal in this case. Okay, so this is the resultant. Okay, so this is the law of parallelogram of forces. And how will you calculate the R? Can anyone tell me? R will be equal to under root of P square plus Q square plus 2PQ cos of theta. Okay, where theta is the angle between the forces. So this is very important. The resultant is under root of P square plus Q square plus 2PQ cos of theta. Yeah. One more law I would like to introduce, that is law of triangle of forces. Okay. Law of triangle of forces. What is the statement? If two forces P and Q acting at a point O as shown, okay, so suppose we have let's say force P acting in this direction, right? And we have, let's say, force Q acting in this direction. Or let's say directly you can write here, draw here as well. Suppose if Q is here, for example. Okay, so force P is like this, Q is like this, then the closing side, okay, then the closing side here will be the resultant. Okay, or let me just explain you why it is like that through law of parallelogram. So initially for law of parallelogram, what we studied, this is our P and this was our Q, right? If you remember, if two forces P and Q acting at point O as shown in this figure are represented in magnitude and direction by the two sides of triangle, okay, then the third closing side in the opposite direction represents the resultant. So maybe use the another pen. So here this system is different, and if this system looks like this, one here and then another one here like this, okay, so two consecutive forces like this, then the closing side will be the resultant but in opposite direction. The resultant will be like this. So you can correlate these two figures, so that you will understand this. Okay, I'll repeat. If two forces P and Q okay, acting as at some point, are represented in magnitude and direction by two sides of triangle. So P and Q are the two sides of triangle, right? Taken in order. Taken in order means first P and then Q. So one after the other. That's why I'm. So that's why the arrows are. Okay, arrows are like this, and then the third side is taken in opposite direction. Will be the resultant, right? Same law you can apply for the law of polygon of forces. So I'll. So this is not just for limited to the triangle, but also for the polygon. So I'll continue this on the same slide. Law of polygon of forces. Okay. Suppose I'll take a point. Force F1 is applied. Force F2 is applied. Force F3 apply. Okay. F3 and F4. Okay. So F1, F2, F3, F4 are the forces. And how this statement will look is if the number of forces acting on a body at a point, some let's say point 2, are represented in magnitude and direction by the sides of polygon taken in order. So let me just draw the figure again. So F1 is in this direction, F2 will be in this direction, F3 will be somewhere like this, right? Little bit longer, F3, and F4 is something like this, little bit shorter. Yeah. Then the closing side is a resultant here, but in opposite direction. So the resultant will look something like this. Okay. So this is how um, the resultant will look like under the action of forces. Any doubt in this? I'll repeat the statement. If the number of forces acting at a point on a body are represented in magnitude and direction by the sides of polygon taken in order, okay, so here F1, F2, F3, F4 we are taking in order, then the closing side taken in the opposite direction represents the resultant. Okay, I hope it's clear. Yep. Any doubt till this? Another basic thing I would like to introduce is the resolution of forces. Okay. Often we are using this term resolving force in x direction and y direction and all. So what is this resolution? Resolution means splitting or subdividing the force into the two components without changing the effect on the body. Okay. Suppose we have a point on a body, that is point O, and we are applying force F. Splitting this force F into the two components without changing its effect on the body is known as resolving the force. So this force we can represent in x direction and y direction. Okay, we are splitting this force in the x as well as y direction. So if let me just um, write down, this is x-axis, this y-axis, and this x-axis. This is same as, okay, this is same as this point is O, fx, fy. Fx is the x component of the force and Fy is the y component of the force, okay, or component of the force along the y axis. What is Fx? Fx is, so now here I will, so this is theta, okay, and if you bring this force down, you will get F cos theta. So Fx is equal to F cos of theta and Fy is equal to F sine of theta. Okay, theta is the angle made by the force with respect to horizontal. Okay, so these are some basic things. Let me uh, give you some more basic idea. Okay, moment, or whenever okay, just one more thing before we go jump into the moment. You have to consider some sign convention whenever we are talking about the forces. Okay, suppose you are considering the force in the in right hand side as a positive, then at that time, if any force is in there in the left hand side, you should consider it as a negative. Okay, or vice versa. Generally we follow the same trend of coordinate axis. Here this is a positive x-axis, here this is a positive y-axis, here it is a negative x-axis, here it is a negative y-axis. Okay, same terminology we follow. If force is in going in right direction, we'll say it as a positive. If it is in the left hand side direction, we'll say it is negative. And same in terms of forces vertical and upward and downward. Okay, remember this. Okay, yeah. Before we jump into the resolution, before we jump into the let's say other term, let me just introduce one more term here, that is moment. What is moment? Can anyone tell me? Moment of force. Basically a turning effect, right? Turning effect or the rotating effect caused by a body is called as a moment. So suppose if a body is there which is, let's say, uh, fixed here, or in you apply force somewhere here at some distance, then obviously what will happen, it will create a turning effect or rotational effect, right? And that is called as a moment. And this moment is given by force into the displacement. It, and the unit is Newton meter. Okay, so here also you have to use the sign convention. If it is a clockwise, you have to use positive sign. If it is a counterclockwise, you can use negative. Okay, negative moment is counterclockwise, positive moment is clockwise. Okay, one more term related to the moment, couple. What is couple? Anyone? Two equal forces, okay, but in opposite direction, separated by some distance d. Okay, then the effect created by it is called as a moment. So you can clearly see here, um, moment is equal to F into D. Okay, F is the force applied and D is the distance between these two forces. Okay, so this is couple. So here it is a clockwise couple or clockwise moment. So you can uh, re replace this as, let's say, a moment like this, and let's say if it is counterclockwise, then the system will just look opposite. Okay, I hope it is clear till this. If you have any doubt, feel free to ask. Okay, let me check if any other basic thing is remain. Yeah, yeah, we have some more topics to discuss today. Yeah, we Newton's law. I think Newton's first, second, and third law. I think it's good when we study the dynamics part. Okay, because the terms such as acceleration um, and all are there. So yeah, otherwise we can discuss at this point itself. So let down heading first law, Newton's first law, second law, and third law. These are very basic laws. Newton's first law, third law, second law, and third law of motion. So what is the first law states? Every body continues to be in rest or in the uniform motion unless it is compelled to change the state by some external force. Okay, um, body will try to be in rest or in the uniform motion unless and until you apply some external force on it. So that is the first law. So unless, suppose if you have body at rest, it will remain in rest until and unless you apply some external force on it. Okay, how much and all, we'll see it later. What about the second law? Rate of change of momentum of body is directly proportional to the impressed force, right? So you can say here force is directly proportional to the rate of change of momentum. Okay, and momentum is what? Mass into the velocity, right? So generally we use F is equal to ma, or F is equal to kma as um, expression in order to solve the problems on second law. Okay, what is third law of motion? Yeah, this is important whenever we study some problems in statics as well. This law states that every action there is always equal and opposite reaction. Okay, suppose if this surface is there, on this surface if I put block of weight W, okay, then the surface or the floor here will also give an reactive force on the block which is of the same magnitude as that of this W. Okay, so suppose if you draw the free body diagram of this, so how free body diagram of surface will look something like this. On surface we have the W force, right? This is the action, and surface is giving the reaction. Okay, here the R is the reaction. Okay, and the value of R in this case is equal to the W, but in just in opposite direction, right? So this is what you have to consider whenever we draw the free body diagrams, because we'll draw the free body diagram of a body, not the surfaces. So you should consider the reaction forces as well whenever we draw the free body diagrams. Okay, yeah. Now one major point before as a, let's say, theoretical background for this subject is force system. Write down heading force system. The force system are either coplanar or non-coplanar. Okay. Coplanar force system. Can anyone tell me what is the difference between them? Name itself indicate. If all the forces acting on the body lies in the same plane or single plane, we call it as a coplanar force system. Okay. But if the lines of action of all these forces lies on the different planes, okay, or will not lie on a, let's say, same plane, then we call it as a non-coplanar force system. Okay, so let's take a simple example here. mm, we have bar. Okay, any forces which are in x and y axis, you can say it as a coplanar. So on this bar, if I apply force in this direction or this direction or this direction, this, but all forces are in the same plane, that is xy plane, right? None of the forces in z direction, which is coming out of the plane or out of this screen or going towards screen. So all these forces are coplanar. Okay, but let's say imagine a 3D figure x, y and z, and here if you have body, some forces are in the z direction, some are here like this. So here, let's say this force is coming out of the plane xy, then it is no more coplanar, right? Some forces are in the different plane as well. So ultimately, you can say this is a non-coplanar force system. Okay, why we have to study this, I'll explain. Okay, um, this will tell us which equation of equilibrium you have to apply in order to understand um, this force, or in order to study these force systems. Coplanar forces can either be concurrent or non-concurrent. Just brief um, classification of this: concurrent and non-concurrent. There can be, let's say, parallel collinear. We don't have to look into that. The classification is like this. Okay, parallel will be, of course, non-concurrent, right? And collinear will, of course, concurrent. So no need to go into the subtypes and all. These two are broad classification, and it will give us the clear-cut indication of what kind of force system it is. And similarly, um, in non-coplanar force system, we can have concurrent and non-concurrent. Okay, so I hope you understood the difference between coplanar and non-coplanar. Coplanar force system is that whenever the forces in the system lie in a single plane, and if forces are not lying in a single plane, we call it as a non-coplanar force system. Okay, what about the concurrent? So we should say it like this: coplanar concurrent force system. What is this force system? Coplanar concurrent force. It is if the lines of action of forces pass through single plane, okay, then they are coplanar. And if they pass through a single point, then we call it as a concurrent. Okay, first try to understand the definition of concurrent only. What is concurrent force system? If the lines of action of forces in the system passing through single point, then we call it as a concurrent force system. Let me just give an example. So this point is O. One force is going in this direction, one is coming in this direction, one is going in this direction, this direction. For example, F1, F2, F3, F4, F5, F6. Okay. So basically, these all six forces are passing through point O, right? That is single point. Hence, this force system is concurrent force system. Okay. So this concurrent force system is possible not only just in coplanar but also in non-coplanar, right? So that's why um, we may have coplanar concurrent force system or non-coplanar concurrent force system. I hope you understood till this. And what is non-concurrent force system? Non-concurrent force system is that if the line of action of forces in the system, let's say, or if the line of action of forces in the system are not passing through a single point, then you call it as a non-concurrent force system. Let me give an idea. Suppose if we have a beam like this. On this beam, one force is acting in this direction, another one is in this direction. So clearly these forces are not lying on the same or not passing through single point, right? Even if, let's say, if I apply some kind of force like this, um, not possible that all three are passing through single point. So that's why, because it's it's acting at a different places with some offset. So this kind of situation, whenever the forces are not passing through single point, we call it as a non-concurrent force system. And this non-concurrent force system possible in both coplanar and non-coplanar. Okay, so that's why you may have coplanar non-concurrent force system or non-coplanar non-concurrent force system. Okay, so these are four different force systems you have. Okay, coplanar concurrent, coplanar non-concurrent, non-coplanar concurrent, non-coplanar non-concurrent. Are you following? Hello, is it clear till this? Do you have any idea, or if you have any doubt, let me know. Yeah, okay, thanks for your response. Okay, you know equations of equilibrium, right? What are the okay, before we jump into that topic in detail, can you tell me in which system see, our focus for this subject is only on coplanar force system. Okay, we will not study non-coplanar because we cannot draw 3D diagrams, okay, on paper, and so our, let's say, focus is mainly on the coplanar force system. Clear? So we so it is very simple. You can draw the figures on two-dimensional paper, two-dimension plane, and then solve the problem. So I'll clearly write here coplanar on current force system. So our focus is only on mainly on basically coplanar concurrent force system and coplanar non-concurrent force system. Yeah. Can you tell me out of these two, uh, in which system you can expect a moment to generate? Okay, the first force system is coplanar concurrent force system, and second system is coplanar non-concurrent force system. Out of these two systems, in which system you expect the moments will generate? Anyone? Yes, coplanar non-concurrent, because if I have point O and forces are, let's say, like this, one in this direction, other direction, P, Q, R, S, and let's say these are the forces and O is the point. All forces are passing through single point. And what is moment? Moment is equal to force into displacement. So with respect to the this point you don't have any displacement, so they are not creating any moment or turning effect out of here. Okay, so that's why in case of coplanar concurrent force system only you will deal with the forces, not the moment. Whereas in case of coplanar non-concurrent force system, you not only deal with forces but also with the moments. Let's take an example. If we have a beam and let's say force is applied here, that force is at certain distance, another force is there, let's say F2, um, that is at a distance D2, right? So moment created by the first force is F1 into D1, and moment created by second force is F2 into D2. Okay, this is the clockwise moment and this is the counterclockwise moment. Okay, so this system is, coplanar non-concurrent. F1 and F2 are not passing through single point, right? So you can clearly see in case of coplanar non-concurrent force system, you don't have to just deal with the forces, you have to deal with the moments as well. Whereas in coplanar concurrent force system, you just deal with the forces. Why I'm telling you this? Because our first topic which we have to study here in this subject is free body diagrams and equilibrium. Okay, the word equilibrium is very important. And we have equations of equilibrium. Okay, so in order to study that topic and in order to understand what are the equations of equilibrium and which equations of equilibrium will apply in case of coplanar concurrent force system and in case of coplanar non-concurrent force system, we should know this background. Okay, can you tell me when you say body is in equilibrium? Yeah, anyone? Yeah, summation of all the forces is zero. Yes, you can say like it like this. Okay, so basically if body is there, sum of all forces acting on the body is zero, then you can say body is in equilibrium. So whenever you deal with a coplanar concurrent force system, the equations of, so either the equations of the equilibriums are like summation of all forces in x direction is zero. Okay, Pranav, you are correct, but yeah, not only in x direction but also in y direction and but also the moments. Okay, yes, right. So out of these three, these two you will apply in case of coplanar concurrent force system, but you have to apply all these three in case of coplanar, or let me um, write it here, summation fx, summation fy, summation m equal to 0. All these three you will apply in case of coplanar non-concurrent force system. Okay, I hope now you got the idea that why we studied this force system before, so that from the next class, whenever we solve questions, we'll be able to know which equations of equilibrium you have to apply there. Okay, so yeah, we are at the end of the session, and yeah, as I said, this was just an introductory session to you to know what are the basics you need um, in order to study these subjects in detail. Okay, so from tomorrow onwards, we'll start with the free body diagrams and equilibrium. Mainly our focus will be solving the problems, a little bit of theory in between. Um, because majority of basics we have studied today itself. Okay, um, and once we are done with this, then we'll start the friction topic. Okay, any doubt till this? Please let me know if you are fine with this space. Either we can increase or um, we can make it a little slow. And if I'm going too fast from one side to other, you can ask me to stop in between. I'll wait until you complete writing. Okay. Yeah. So that's all I have for today. If you have any doubt, feel free to ask. Otherwise, we'll close this session. Okay. Thanks. Thanks, Pranav. Thank you, everyone. Thank you all. Bye. We'll meet again in the next session.